Today's lesson is linear measure. We're going to be talking a lot about line segments and application of algebra with line segments. A couple of vocabulary words we need to get out of the way is, because you're going to hear them quite often, is rules in geometry that are accepted as true. We call those postulates. So for example, there's something called the ruler postulate, and the ruler postulate just says that you can measure length of a segment with a ruler. It's kind of like one of those, common sense things. The other vocabulary word you're going to hear a lot is called a theorem, and those are rules that have to be proven. For example, Pythagorean's theorem. He had to prove that a squared plus b squared equaled c squared, and once he proved it, we now had a formula that we can use forever and ever and ever. We call that a theorem. Okay, so also some notation that you're going to see a lot. This one's extremely important because you will see this on a test or a quiz and any of your worksheets. And you need to know that when you just have two capital letters, it's asking you for the length of a segment. So with that one, you're expected to give a number or some sort of measure that you've taken from the length of a segment. And then if you see just AB with the bar on top of it, that means just segment AB. Okay? So let's see what I'm talking about here. See how it says AB equals? That means you need to find the length of segment AB. And the way that you can do this, the length of a segment is represented by the absolute value of one of your x's subtracted from your other x. And you remember what absolute value is? Absolute value is how far away a number is from 0, so on a number line. So if I had -6, -6 is 6 away from 0 on the number line. If I had a +6 and I took the absolute value of it, it would be 6 away from 0 on the number line. So distance is always going to be an absolute value. It's just how far away is it from 0. We don't ever want a negative when we talk about length. That's very important too. Length is always absolute value. Okay, so we're just taking one of our x values, -6, and we're subtracting our other x value, 13, and it's all in the absolute value. Okay, -6 minus 13 is -19. And the absolute value of -19 is 19. So the length of this whole segment is 19. So AB right here would be 19. Alright, so now you try number 2. Remember, we want the absolute value, or the distance away from 0, that happens between 17 and 31. So go ahead and pause the video and take a second to figure out what the length of AB is. Okay, and you should have gotten 14. Could have done it two ways. Remember, you're just subtracting your x values. You can do 17 minus 31, or you can do the absolute value of 31 minus 17. Either way, you're going to get 14 once you take the absolute value. Okay, so now we're going to be given measures of various segments within a segment. So SR is a segment that exists. SR is a segment that exists within segment ST, and so does RT. They both exist within the whole segment ST. So when I write the notation like that, I'm telling you I'm talking about segment SR, just in reference to it. So this is segment ST, this is segment RT. I don't want to know the measure of it here. I just want to tell you that these are the segments we have. Now down here, it says capital RS is 6. So the length of S to R, or R to S, is 6. And the length of TR, so T to R, is 4. Okay, and if I ask you to find TS from S to T, or T to S, what would the length from here to here be? Well, from S to R is 6, from R to T is 4, so So the length of the entire segment is 6 and 4, which is 10. It's like if I asked you to tell me how tall you are from belt to feet. Let's say you were 3 feet from your belt to your foot. And from your belt to your head, you're 3.5 feet. So total, you would be 3.5 feet plus 3 feet, which is 6.5 feet. And that's all we did here with the segment. So go ahead and see if you can figure out number 5. You need to draw a picture. Pretty soon I'm not going to be giving you pictures. And you need to label the picture with the measurements given. Pause the video and tell me what you get. Okay, so you should have gotten that TS is a total of 24. We had SR or RS, which was 5. We had RT, which was 19. And total, we take SR and we add it to segment RT. Actually, these are measures, so I get rid of the segment here. We add it to segment RT, and that's going to give us segment ST, the whole length. So 5 plus 19 is 24. Okay, so now we get into the segment addition postulate. And remember, the postulate means it's a rule that's accepted as true. We didn't really have to prove that you can add two things to each other to get the whole thing. That's just a true statement. There's no proof involved. Now, the segment addition postulate, it seemed very, very easy when we were doing it with just numbers. But pretty soon here, we're going to get into variables and having to set up equations. So it's important that you really, really have a strong foundation and have this type of postulate memorized. The segment addition postulate says exactly what we just did, but with letters instead of numbers. It says that the length of this segment PQ, or from here to here, plus the length of this segment QR, so from Q to R, makes up the entire segment PR. Okay? So like we did before, let's say this was 3 and this was 10. PQ is 3 plus QR, which is 10, equals the length of the whole segment, which is PR, which would be 13. Okay? But now we're going to do it with algebra. You definitely want to have an example like this in your notes, and you definitely want to have the postulate down. Okay, so I'm going to take that same thing, except now I don't have P, Q, and R. I have A, B, and C. And it says that B is between A and C. That's just a given. Here's B between A and C. AB is X. The whole length here is X. BC is X plus 6. The whole length from B to C is X plus 6. And AC is 12. This whole length from here to here is 12. We're going to solve for X and BC. So segment addition postulate, let's set it up before we start. We know that part of the segment AB plus part of this segment BC make up the entire segment from A to C. So this is the postulate as it pertains to our problem. Now we're going to do substitution. AB equals X. So where it says AB here, I'm going to substitute it with X. BC, they said, was X plus 6. So where I see BC, I'm going to substitute it with X plus 6. And that'll equal the length of my whole segment from A to C, which we said was 12. So I'm going to replace this AC here with 12. And now we're just using algebra to solve. X plus X is 2X plus 6 is 12. I would subtract 6 from both sides of my equation, and I would get 2X, that goes to 0, equals 6, so X equals 3. Now make sure we finished answering the question before we move on. It says solve for X and the length of BC. Well, I found X, that's part 1 of my solution. But now I have to solve for BC. Well, here we said that BC equals x plus 6. So to find the length of BC, I just have to substitute this 3 in for this x. So BC equals 3 plus 6, which is 9. And what you always want to do, even though it asks for just BC, we also want to make sure we did this correctly. So we need to plug it into everything. BC was 9, x here was 3, and we need to check to make sure that 3 plus 9 does in fact equal AC, which is 12. And 3 plus 9 is 12, so we're good. Okay, so look at number 7. It says that SR is 3x minus 1. So from here to here is 3x minus 1. RT is 13. From R to T is 13. And ST, the length of the entire segment, is 21. So we want to, given that R is between S and T, we want to find the value of X and the length of SR. So same thing, we're going to set up the segment addition postulate as it pertains to this segment. SR from here to here plus RT is going to equal the length of our whole segment, ST. And now we're just substituting. SR equals 3x minus 1 plus RT, RT is 13, equals the length of ST, which is 21. Okay, we want to combine our like terms. We have a negative 1 and a positive 13, so that gives us 12. 3x is in front of that, equals 21. We will subtract 12 from both sides of our equation. Okay, then we bring everything down. 3x, that goes to 0, equals 12 minus 21. Punch that in your calculator if you don't know it. It's 9. We're going to divide by 3 on both sides of our equation. So we'll get x equals 3. Make sure we answer the question before we move on. It says find the value of x and the length of SR. So we're going to plug x back in to SR. So remember, SR equaled 3x minus 1. We found x was 3. So SR equals 3 times 3 minus 1. 3 times 3 is 9, minus 1 is 8. So SR equals 8. And we would just write that off here. SR equals 8, circle it, x equals 3. And we just want to check that 8 plus 13 does in fact equal what we said it did, which is 21. And that's true. So we're good. Okay? And for the last one, I want you to do this on your own. You should be drawing this on your notes. Don't just write this part down, but you need to have a picture of it, and you need to fill in the picture. These ones later on, I'm not going to always give you a picture, so you have to draw that and measure and write in your measurements. Okay, go ahead and pause the video. We're going to find x, and we're going to find the length of SR. Alright, we should have gotten x equals 7.7, and this probably scared you a little bit because you guys hate decimals. And remember, in our class, a general rule is that we always round to the nearest tenths. So x is 7.7, and then when we plug that x into SR, we would have gotten 16.4. If you got it, go ahead and move on to the end of the video, or to the next part of the video. But if not, I'm going to work out the algebra for you. Right here we have segment addition SR. Take SR, we're going to add it to RT, and that's going to equal the whole segment ST. Filling in for SR, we have 2x plus 1. Filling in for RT, we have 5x minus 9. And that's going to equal our ST, which was told to us as 46. Okay. Combine my like terms. 2x and a 5x is a 7x. A positive 1 and a negative 9, that's 1 minus 9, which is negative 8, equals 46. I add 8 to both sides of my equation. 7x equals 46 plus 8, which is 54. and then I divide by 7 on both sides. So that was what gives me x equals, and I think it was like 7.1 or 7.714, something like that, but we just want the nearest tenths, 7.7. That's the first part of our answer. Now we're going to come back here, and it said to find SR. So we're going to take that x equals 7.7, and we're going to plug it into here. 2 times 7.7 plus 1 is about 16.4. But remember, I also want to check here to make sure that I did the solving right, because I should be able to plug x back into here and here and get 46 for my total sum. So then I did 5 times 7.7 minus 9, and I got about 29.5, sorry, 29.5. Okay, so 16.4 plus this 29.5 should equal about 46, and it actually comes out to 45.9, but that's because we rounded the to the tenths here. So really, this, if we had kept all of the repeating digits, we would have gotten 46 when we plugged in x. Okay, the next vocabulary, it's very easy, but the application of its algebra is when it gets difficult. If you have a segment that has a bisector in it or has a midpoint in it, then a segment or a midpoint or a segment bisector is going to divide a segment into two equal parts. And you're going to see these symbols here, they should be straight lines, through the segments AB and BC. And those symbols are called hash marks, and they mean that AB is congruent to BC, which means that B is the midpoint of AC. And if B is the midpoint of AC, AB is congruent to BC. So a segment bisector divides a segment into two congruent parts. So the segment bisector is dividing a segment into two congruent parts or two congruent segments, and the midpoint is in the middle, or it is the point where the segment has been bisected. Okay, you definitely want to have those definitions in your notes, and you also want to have these markings on a picture of a segment, because these markings, you have to be able to identify them and know that they mean that AB is congruent to BC. So let me write that for you. AB is congruent to segment BC. Okay, this is how you're going to see it as an example. M is the midpoint of segment AB. So immediately we should draw a segment AB and then put a point M in the middle, and we know that it's the middle because we're going to put our two little hash marks here. AM is equal to 3x plus 4. So here to here is equal to 3x plus 4. And MB is equal to x plus 20. So from M to B, it equals x plus 20. Well, now, in order to find the value of x, segment AM, segment MB, and AB, we have to take algebraically what we set up verbally. We said that M was the midpoint, so that means that AM, segment AM, is congruent to segment MB, right? And that also means, coming down into algebra, that the length of AM is equal to the length of MB. And now we just plug and chug, because we already know that AM was assigned a value, 3x plus 4, and MB was assigned a value, x plus 20. So we're just substituting in for what we were told they equal. And then we solve. We'll subtract x from both sides of an equation. We get 2x plus 4 equals 20. And then we'll subtract 4 from both sides. I'm going to come over here. And we get 2x equals 20 minus 4, which is 16. So we divide by 2. And we get x equals 8. Okay, just check your question, make sure we're done answering it, and no, we're not. It wanted us to find x, AM, MB, and AB. So x equals 8, we found that. AM, we just plug x in for AM. So 3 times 8 plus 4. 8 times 3 is 24 plus 4 is 28. So AM equals 28. And because this is the midpoint, we should get the same thing for MB. X plus 20 is 8 plus 20. So 28 here as well. So we did solve correctly. MB is 28. And now we need to check to make sure that AB equals AM plus MB using segment addition postulate. So AB equals AM, which we said was 28, plus MB, which we said was 28. So AB equals 28 plus 28, which is 56. Okay? And always make sure when you start a problem that you know exactly what you're trying to find so that you don't skip an answer, because you will get points taken off, and that's probably going to get you a lot when you take your exit quiz, is not finding the lengths of the segments. Alright, I'm going to go ahead and let you try this next example on your own. First, you want to make sure that you draw a picture. Then, make sure you're finding X, AM, MB, and AB. Make sure you answer all the questions. Go ahead and pause the video, take a minute, and let's see if we get the same thing. Alright, for some of you this is probably going to be very surprising because this is not exactly like the problem we just did. And the crazy thing about geometry, and the reason geometry is so hard, is all problems are a compilation of everything you know. So this problem is actually going to be a combination of the segment addition postulate and the midpoint theorem. So let's draw our picture. M is the midpoint of segment AB. So here's AB, here's M. It said midpoint, so I need to draw those two hash marks so we know that those two parts are congruent. It says AB. Oh, well, give us the whole length of AB, which was 24 plus X, and MB equals X minus 2. Well, segment addition postulate says that we can take AM and add it to MB, and that'll equal the whole length of our segment AB. And the reason I'm going to segment addition is because I know that I have the whole length of this segment. In that previous problem we did, we didn't have the whole length of a segment. We just had the length of this part and this part. So we couldn't use segment addition postulate, but now we have the length of the whole segment. What we don't have is AM. Well, that's why we marked our picture. AM equals MB. So AM also equals X minus 2. So now we can take AM, plug it into what it equals, X minus 2. We can substitute MB for X minus 2. And that all is going to equal the length of AB, which is 24 plus X. So combining like terms, X and an X is 2X. A negative 2 and a negative 2, that's a negative 4, equals 24 plus X. Subtract X from both sides, and I get X minus 4 equals 24. Add 4 to both sides. I get X equals 28. So that's my first one. Now I have to find AM. So I plug it into here, this X. 28 was X. Subtract 2 is 26. Good. And since M is the midpoint, I better get the same thing for MB. X is 28 minus 2, which is 26. I'm good there. And the length of AB, well, I could just take 26 and 26 and add them together. I'm going to plug it into the X into this AB because I want to make sure that I did it right. 24 plus x is 24 plus 28, which does in fact equal 52. And so does 26 plus 26. So that one is a little bit tricky, and you will see problems like that. So you always have to draw your picture, and you always have to have access to all of those postulates and theorems. Because if you don't know the segment addition postulate, you wouldn't know how to do this problem. All right, go ahead and start on your practice worksheet. I highly, highly recommend you do all the problems on there, because the exit quiz is a little bit challenging, like they have examples like this on it. Good luck.